So what are the endogenous cannabinoids? These chemical substances that everybody makes. Right? You make them, I make them. You've been making them basically from the time that you were conceived, and you are going to make them until the time that you die. Whether or not they have the impact and the biological functions that I'm about to describe will depend a lot on whether or not you are using your own endogenous cannabinoids to park in those receptors that you also have from birth until death, or whether or not you are tickling those receptors or strongly activating those receptors using some external source like cannabis, THC, etc. The two main endogenous cannabinoids that we want to consider are anandamide, which we will refer to as EAE, so anandamide, and another one which is arachidonyl glycerol, which we will abbreviate 2AG. So let's just take EAE and 2AG, lump them together, and talk about the endogenous cannabinoids, just to make it simple. But if you want to do the deep dive on anandamide versus 2AG, please be my guest. The endogenous cannabinoids are released from neurons. What are neurons? Neurons are nerve cells, and nerve cells should be conceptualized like this. You have presynaptic neurons and postsynaptic neurons. Presynaptic neurons basically contain little vesicles, little bubbles full of neurotransmitter, which are chemicals. And when neurons are stimulated electrically, and that could be from a thought, it could be from the desire to move, it could be because of a drug, it could be because you're hungry, the relevant neurons will vomit out or will fuse, as we say, those little packets, those little bubbles of neurotransmitter into the gap between the pre and postsynaptic neuron. We call that a synaptic cleft or the synapse. It's a little gap, a little space, and the neurotransmitter flows across that synapse, and some of it will park in little parking spots that we call receptors on the postsynaptic neuron side. Depending on which neurotransmitter it is and a bunch of other things not worth going into right now, the parking of that chemical in those neurotransmitter receptors will either cause that neuron on the postsynaptic side to itself release neurotransmitter elsewhere, or it will quiet it down, so-called excitation and inhibition. That's kind of neurotransmission in a nutshell. If you don't understand it, no big deal. It's not going to prevent you from understanding today's discussion. If you understand even a small fraction of what I've just said, then it's going to allow you to understand not just today's discussion, but a lot of neuroscience with a lot more nuance and depth of understanding. The key thing to know about the endogenous cannabinoids is that unlike most neurotransmitters, they are released from the postsynaptic side. So what happens is neurotransmitter goes from presynaptic neuron to postsynaptic neuron, but under certain conditions, the postsynaptic neuron itself releases a chemical. And that chemical goes backward, what we call retrogradely, to the presynaptic neuron, binds to receptors there, and changes the probability that the presynaptic neuron will release neurotransmitter. Put simply, endogenous cannabinoids tend to decrease the probability that a neuron will release neurotransmitter. They are sort of a brake on the system. They are a way of shutting down the communication between neurons, regulating it. Not to make it completely quiet, but to adjust the levels with a lot of nuance. Now, the other thing that the endogenous cannabinoids do is sort of a mind bender, because we're talking about cannabis, and a commonly known feature of cannabis and marijuana consumption is disruptions in short-term memory. And there is essentially zero debate as to whether or not that occurs. And we'll talk about the mechanisms a little bit later. And yet, endogenous cannabinoids, the chemicals that you naturally release from these postsynaptic neurons that travel retrogradely back to the presynaptic neuron, actually can lead to strengthening of connections between the presynaptic neuron and the postsynaptic neuron through a process called long-term potentiation, or LTP. They can also cause what's called depression of communication between a presynaptic neuron and a postsynaptic neuron. Long-term depression has nothing to do with depression as a psychological state or as a illness. Long-term potentiation and long-term depression simply refer to the probability that one neuron will be able to stimulate and activate another neuron. And as I just told you, the endogenous cannabinoids can either turn up the dial or turn down the dial. They can either increase the probability or decrease the probability that a given connection between neurons will function more or will function less. So if you think about the communication between neurons as a crosstalk, as a conversation, well, the endogenous cannabinoids can dictate whether or not that conversation is likely to occur or not to occur. Think of them as either, putting someone at the top of your text chain in your phone, which would be long-term potentiation, or essentially blocking their number, which would essentially be long-term depression. So if you're getting the impression that the endogenous cannabinoids are working in a number of different ways and it's not very straightforward, you're right. In fact, that's the message that I'd like you to take away. The endogenous cannabinoids are sometimes increasing neuronal communication. This can lead to increases in mood or increases in the likelihood that someone will talk a certain way or behave a certain way or feel a certain way. They can also lead to decreases in synaptic transmission, that is communication between neurons, in ways that will make somebody's mood lower or will make them less hungry or more hungry. And here's the really key thing. There are two kinds of endogenous cannabinoid receptors referred to as CB1 and CB2. And we can say with confidence that CB1 is highly enriched in the nervous system and especially within the brain. It's found not everywhere, but almost everywhere in the brain and elsewhere in the nervous system, so spinal cord and other aspects of the nervous system. CB2, the cannabinoid receptor, CB2 is largely located in the tissues of the body, including the immune system, the liver, even the genitals, etc. So what this means is that the endogenous cannabinoids are having these sorts of effects on neurons that I talked about, but they are also having effects on immune cells, on reproductive organs, on liver, on digestion, on hunger, etc., through mechanisms that are divorced from the function of the nervous system of neurons. Now, in reality, no system of the brain and body is divorced from the nervous system because the nervous system is controlling everything. It is really the master controller, and everything's feeding back to the nervous system, so it's a two-way street. But the simple way to think about it is CB1 receptors are mainly in the nervous system and CB2 receptors are mainly in the body, and endogenous cannabinoids, again, EAE, anandamide, and 2-AG, arachidonyl glycerol, are impacting CB1 and CB2 receptors. Today, we're mainly going to talk about CB1 receptors because they are the ones that are responsible for most of the familiar effects of cannabis. But the key takeaway at this point is to really understand that the major effects of your endogenous cannabinoids on these receptors, in this particular CB1, are very nuanced. It depends on context, depends on which neurons. It's, sometimes increasing communication between neurons, sometimes decreasing it. And then along comes cannabis. And that cannabis, again, can arrive by smoking, by vaping, by edible. And cannabis contains THC and CBD that potently bind the CB1 receptor. And now the effects of the CB1 receptor being occupied by THC or being occupied by CBD are not very nuanced. In fact, they are very predictable. And especially important is to understand that they are so strong and they park in that receptor with such affinity, with such force and precision and stubbornness and refusal to leave that receptor, that they completely outcompete the endogenous cannabinoid system. In fact, they leave the endogenous cannabinoid system essentially dysfunctional, which in some cases may be a good thing, but in most cases is going to lead to problems of various kinds. And we'll talk about what sorts of problems. And again, I feel obligated to say, this is not me saying don't ingest cannabis or THC or CBD. That's not what I'm saying. What I'm saying is if you evaluate the potency, that is, in technical terms, it would be the affinity with which these compounds, THC and CBD and CBN, bind to these endogenous receptors. That would be like a howitzer gun, like a cannon going off, as compared to endogenous cannabinoid, whether or not it's EAE or 2-AG, which is more like a cap gun level of activation, at least in this analogy. So now you have what, at least I would like to think, is a fairly complete understanding of the different varieties of cannabis, at least at a broad sweep, and the different biological effects that they can have, at least in terms of the major receptors and in retrograde signaling, et cetera, et cetera. Now let's take a step back into the real world and evaluate or think about what happens when somebody smokes cannabis or ingests cannabis by way of edible or a tincture or something of that sort. Cannabis is very fast to enter the bloodstream. In fact, within 30 seconds, it's going to enter the brain and permeate throughout the brain and body. That's very, very fast. I mean, when you contrast that with something like alcohol or even nicotine, depending on how the nicotine is delivered, that is a very fast delivery of the psychoactive and biologically active compound, which in this case is THC and CBD and probably some other things as well. So within 30 seconds, it reaches the brain and bodily tissues. And within 30 to 60 minutes, it's going to reach its peak concentrations and have its peak biological effects. Those aren't always the same thing, but in the case of cannabis, and again here I'm using cannabis as a kind of umbrella term for THC and CBD, the effects are going to peak at about 30 to 60 minutes after bringing those compounds into the body in some way or another. And the effects tend to last anywhere from 3 to 4 hours, although there's some variation on that depending on individual metabolism, whether or not somebody is familiar with the compound, believe it or not, psychologically familiar, but also biologically familiar, or whether or not it's a first-time use or occasional use and so on. THC and CBD and other components of cannabis are highly what we call lipophilic. That is, they have an affinity toward and they can actually pass through fatty tissues. Now, every cell in your body, but especially neurons, have a double layer of fat on their outside. And of course, when people hear fat, they always think, ooh, fat's bad, fat's bad. You know, most of the world seems to want to lose fat or bodily fat. Here we're talking about the fatty membrane, the barrier around each tissue. In this case, we're talking particularly about neurons. And THC and CBD and the other components of cannabis are highly lipophilic, so they can get into essentially all cells just simply by flowing into them. They will also remain in those cells for a long time. So I know that a number of people, depending on whether or not they get tested for work or for sport or otherwise for cannabis or CBD and THC, don't take this as a strict number, but typically if one ingests CBD or THC, smokes cannabis, ingests by orally, etc., doesn't matter. It's going to stay in that fatty tissue and can be detected for at least as long as 80 days after ingestion. And there's a whole industry as to, how to accelerate the clearance. And it should just tell you that just losing bodily fat isn't going to eliminate it from your system, maybe partially in those fat cells, but certainly intravisceral fat and other fatty tissue that's around the brain and body is going to harbor that THC molecule and the CBD molecule for quite a long while, at least 80 days. Okay, so if someone smokes cannabis or they ingest cannabis, very rapidly gets into the bloodstream, and the components that are psychoactive get into the bloodstream and are immediately able to access neurons and other cells and start having these effects of parking at those endogenous cannabinoid receptors and impacting the signaling between neurons, which leads to the subjective effects of cannabis, including THC and CBD. So let's talk about what those different subjective effects are. Again, this is going to vary depending on whether or not people are ingesting sativa varieties of cannabis. Just to remind you, those tend to be elevated mood, alertness, talkativeness. People who take sativa varieties tend to talk a lot more than they would otherwise. Again, there are exceptions to this. Of course, there are exceptions. I'm sure there are people out there shouting, although I guess if you're the quiet people who don't talk too much, you're probably not shouting, or if you're not doing it on sativa. Joke intended, but in any event, there are exceptions, but there are also general rules. And the sativas tend to meet people sort of mood elevated, energetic, again, the sort of head high, and indica varieties tend to do the opposite, more of a sedative, relaxant, etc. Why and how would they do that? Okay, well, without going into an extensive deep dive into the different neurotransmitter systems of the brain and body, what we know for sure is that CB1 receptors are present on an enormous number of different neurons and brain structures and neural circuits, so that the sativa varieties that act as sort of a stimulant, making people feel happy, because in general they do tend to elevate mood, at least at certain dosages, talkative, tend to make people feel like they have ideas that are interesting, that they might want to share, tend to narrow their context, so tend to increase focus. This is something that's not often discussed about cannabis, but it can, especially the sativa varieties, can increase people's level of focus to particular things, something they're watching or something they're doing, or music allows them to narrow their sense of focus. That's going to occur by activation of CB1 receptors in the so-called prefrontal cortex, which is just behind the forehead. And the prefrontal cortex acts as a strong modulator of so-called limbic circuitry and other circuitry that is more stress-oriented. The way to think about the stress and limbic circuitry, such as the amygdala, which many people have heard about, is that they aren't really circuits for fear and stress. They are circuits that are constantly evaluating one's own internal state, heart rate, et cetera, and what's happening externally. And sorry to say, but the default of those systems is to detect danger, the sort of threat detection systems. And then the prefrontal cortex largely acts as a brake on those systems, sort of like the reins pulling back on a steed of horses that would otherwise just kind of take off. And so the sativa varieties tend to increase CB1 activation in the prefrontal cortex and in other circuitry that then leads to a kind of overall reduction in stress because of the way that prefrontal circuitry can reduce activation of the amygdala. Now that, of course, does not explain why some people become very stressed and very paranoid when they smoke sativa varieties or other varieties of cannabis or ingest other varieties of cannabis. We will talk about the paranoid effect and why that occurs and who might predict that would occur to them in a little bit. But I just want to give you a sense of how this is working because, as I mentioned before, THC and or CBD are going to bind that CB1 receptor, let's say in prefrontal cortex. The neurons of prefrontal cortex is going to bind there. And then there will be a retrograde signaling back to the presynaptic neuron. And in the case of prefrontal cortex, what's happening is it's increasing transmission, increasing the release of neurotransmitter in prefrontal cortex. However, at the same time, the very same THC and CBD that was brought into the system is binding the very same type of receptors, CB1 receptors, in other brain structures, such as the amygdala, and causing retrograde signaling back to the presynaptic neurons in the amygdala, but it's quieting the activation of those neurons. So this is interesting, right? We have the same compounds, THC and or CBD, brought into the body and brain, binding the same receptors, in this case, the CB1 receptors. But depending on where those receptors are located and which brain areas we're referring to, they are either causing heightened levels of alertness and activation of systems that are designed to make you talkative and alertness and mood, et cetera, focus, or they are causing suppression of those circuitries. So we have kind of a seesaw effect here where the same compound is increasing mood and alertness and focus in the prefrontal cortex and is decreasing stress and threat detection in the amygdala. And that's one of the reasons why, especially the sativa varieties of cannabis, allow people to enter these states of focus. Some might even say flow, although I don't want to go into what flow states really are. That's for a different discussion, and it's very poorly defined as it is. And I certainly don't want to give people the impression that cannabis increases flow states, because that's not always the case, and certainly most often is not going to be the case. But the idea here is that this molecule comes into our brain and is shifting everything towards a state of focus, elevated mood, of heightened sense of importance about whatever it is that we happen to be doing. And now, of course, whatever we could happen to be doing could be writing a song, writing poetry, communicating with somebody, but it could also be something as trivial as watching cartoons or watching a movie, which is, not trivial in its own right, but in terms of thinking about the creative aspects or the creativity stimulating aspects of cannabis, not sort of productivity oriented. So narrowed focus, elevated mood, more relaxed and yet energetic. That's the major effects of the sativa varieties, except, and this is a really big, bold-faced, triple underlined except in some individuals, depending on dosage, but also depending on pre-existing neural circuitry and propensity for anxiety, some people ingest or smoke sativa varieties, and regardless of whether or not it's a type 1, type 2, or type 3 variety, okay, regardless of the ratio between THC and CBD, people will experience intense anxiety and paranoia. Now, how do you predict who will experience intense anxiety and paranoia and who will experience intense relaxation, focus, and sense of creativity from ingesting or smoking a type 1, type 2, or type 3 sativa? Well, there is no way to predict that. And there's a lot of kind of what I would call street lore or dorm room lore or kind of not peer reviewed, but sort of peer discussed, among friends and people and acquaintances, lore out there that what one needs to do is simply smoke more, right? Or just ingest more. You hear that. Oh, well, listen, if it makes you paranoid, you simply need to use more. That is absolutely categorically false. Everything we know about the way that THC and CBD work is that they tend to potentiate, that is, increase the effects of these different systems at given synapses and in different areas of the brain and body. That is, if someone experiences paranoia or anxiety from a given strain of the marijuana plant or from ingesting an edible in a particular way or a particular kind of edible, that person is very likely to experience the same effect every time they ingest that strain or variety. This is part of what's led to this enormous industry. I mean, there are a number of different reasons, but this is part of what's led to this enormous industry of highly customized cannabis, where people will spend some time really seeking out the different strains of cannabis and hybrids of cannabis that work best for them and work best for them in particular contexts.